Okay, so today let's talk about, first of all, rate. What is a rate? So define rate. So rate is a fraction, okay? But it's got to be some unit in terms of time, whether it's liters per minute, it could be gallons per second, right? So it's going to be some units. It's going to be a unit of measure, some unit per time, okay? That's our rate. So for us, it's usually going to be liters per minute, liters per hours, right? Could be liters per second, whatever it may be. That's going to be a rate. Later on, we're going to see that rate is also connected to slope, okay? So we'll talk about that in a couple of days, all right? So let's take a look at this example one, okay? It's a swimming pool. We're going to find, first of all, the volume of it. We're going to find out how many liters it holds. So when I take a look at this pool, it's kind of a weird shape, isn't it?
Yeah. Who is swimming this?
Oh, it looks like a fun pool. It's pretty deep. It's 4.5 meters. It's a good deep pool.
What the heck?
I apologize.
It's okay. You just have to...
I landed.
So like,
Like
almost the same font.
Yeah, I know.
It's weird because the top is like
Okay. All right. Give me 5. Shh. Give me 5. Thank you. So if we have, first of all, don't plug it in. Just leave it, Nick. So if we have to find the volume of this thing, and we don't want liters, any ideas?
cubic meters.
Okay. We can do it in cubic meters, and then we can convert our cubic meters. It's not bad. We can convert our cubic meters to decimeters cubed. I move the decimal. Does that make sense? Does that make sense? We can figure, okay, because everything's in terms of meters. Let's get in terms of cubic meters, right? Good job, Aiden. Move the decimal 1, 2, 3, and then we're at liters. Okay? Capiche? Okay, so then it's a weird shape, right? Is it a prism?
Yes.
It is a prism. So there's two ways to do it. One, and the Sasha method. One method is you could make it into a box plus a triangle, right? That'll work, right? That's the way you would have done it originally, right?
It's not a triangle.
Well, if you cut that right there,
Oh, that makes sense.
you got the top box, and then you got this bottom triangle, right? Well, that's one way to do it. Or we could call it a trapezoid, right? We could say the face. This face is a trapezoid. You guys see the trapezoid?
Yeah. Wait.
Do you see a trapezoid?
No. Yes. No.
Let me draw the trapezoid here.
I see a triangle. Oh, I see it.
Do you see a trapezoid?
Oh, yes. Wow.
Okay. So if there's my trapezoid, that's 1.5. That's 4.5, right? And that's 10, okay? All in terms of meters, right? Okay, there's two ways to do this. You could do it the Sasha method, which is perfectly great. But the Sasha method really makes it into two problems, okay? Not wrong, not bad, just different, okay? Or we could do it Bill Davies' way, and Bill Davies say, hey, you know, I'm lazy, so I'm going to try and find the easiest way to do it. So I'm going to make it into a trapezoid. You guys ever see the trapezoid? So we go back to the area of a trapezoid, right? What was that, guys? Remember? Isaac, you said,
Equals
right?
half height times
Base
base
plus
1
base.
plus base 2.
Right? Okay. So that's okay. So here's our trapezoid. What's the height of the trapezoid? 10. So let's go 1/2. Am I going too fast?
Yeah.
Okay.
No.
All right. Okay. Height of the trapezoid is 10. Base 1 is 1.5 plus base 2 is 4.5. And somebody, if you're thinking this, doesn't matter which one you call base 1, base 2. Everybody okay with that? Does not matter.
Yeah.
Right? They're interchangeable, right? Just because of the way you add, it doesn't matter, right? Okay, now, please use calculators, you guys. You're going to do all the problems right and make a mistake, and I don't want you to do that. So 0.5 times 10 times 1.5 plus 4.5, and I get 30. Okay, so I get 30, and that's in terms of meters squared, because area, right? That's meters. So this thing's 30 meters squared, okay? How am I doing?
Good.
Great.
Okay. So then if I want the volume of a prism, remember, what's the area of the volume of a prism?
Base times height.
Yeah, so the volume is the area of the base, right? Times the height. Okay, now, the base we just found. The base is the trapezoid, right?
Wait, are we still doing trapezoid?
Yeah, well, we're going to find the whole thing now. So the whole thing, to get the whole thing, we got to find the area of the base. The base is the trapezoid, right? So it's going to be volume is equal to 30, because that's the base, right? Meters squared times the height. Now let's take a look at the pool. Now you got to be careful, because the pool, in a sense, is knocked down. I mean, if you really want the height of the pool with the trapezoid as the base,
Wouldn't that be 5?
it is 5. You guys agree, 5?
Magical.
It's just got knocked over, right? It's got knocked over. So the height is really 5. If we were to pick it back up again and make it into a trapezoidal prism, the height's 5. Now, of course, all the water would pour out, right? That'd be kind of silly. But the height is 5, okay? So then, that's in terms of meters. Multiply it, I get 150 meters cubed, right?
Because yeah.
For 2 reasons. One is volume, and the other is meters squared times meters cubed, right? Everybody good on that? Everybody good. Thumbs up. I want to see it. Thumbs up. Go ahead and be careful. Sideways thumbs. Any sideways thumbs? It's okay.
Wait,
Yeah.
wouldn't it? Okay, I'm confused because it's 30 meters squared
Mm-hmm.
and 5 meters,
Right.
and it's cubed.
Right, right. So I don't know how much Mr. Bard got to you, but m squared times m squared times m is what?
Another
We
Yeah.
don't know that.
root,
You don't know that? Okay. All right.
another exponent.
Right. So you'd have m times m, right? M times m makes m cubed. You okay with that? Plus, the easier way then also is we know it's volume. Volume is always 3D, so it's got to be cubed. Now, we want liters, right? So come over to chart, and we got meters cubed. That's what we got. We got meters cubed, right? We want that. So let's move decimal.
Oh, it's just
1,
like-
2, 3. That way. 1, 2, 3, that way. Right. Now, your answer, before you put your answer down, think about this swimming pool, right? How many of these would fill that pool? It should be a lot, shouldn't it?
150.
Should be a lot, yeah. And so does your answer make sense? I mean, so if we move the decimal, you know,
150,000.
1, 2, 3,
4 zeros in all, right?
1, 2, 3. So it's 150,000 liters.
Wait,
Okay. Yeah, go ahead. Go ahead.
that makes sense. You go 4 times.
No, I only moved it 3 times because there's a 0 already here,
Oh,
right? I only moved it 3 times because there's a 0 already here, okay? So that kind of makes sense to me because it's, you know, it's pool and it's going to take a long time to fill it with just one of these. In fact, we're going to need 150,000 of these to fill the pool, right? Okay. Now, let's talk about a rate. So let's fill a pool, okay? So now we got a rate. This pool can be filled by a hose that delivers 20 liters of water a minute, okay? So how many hours will it take to fill the pool? So what do you think? How are we going to do that? Go ahead, Isaac.
Once you divide 20 by 1,000.
Absolutely, 150,000 liters divided by 20 liters per minute, right? Okay.
do you need to do the per minute or can you just do it?
Okay, I wanted to leave this because you don't need it, but I want to show you some, okay? So, we're going to cancel words. You okay with canceling words? Cancel words. So what cancels? What are you left with?
Minutes.
What are we looking for?
Minutes.
Well, time. We're going to get time. We'll get hours and say, we're going to get time, aren't we?
Yeah.
We are going to get time. So, Isaac, what'd you get for an answer? 75.
7,500.
7,500
Divided by 60.
minutes, right? Right. So, if we need hours to divide that by 60
125.
minutes, right? Boom, boom. What'd you get? 125
This is a lot.
hours. So then, right off the bat, I'm thinking to myself, man, if I'm at a pool party, this is like not going to work, is it, right? How many days is that? How many days?
17 weeks.
How many days? Aiden, did you get it? Aiden, did you get the days?
125 days or 17.85714,286 weeks.
hold on, 125 divided by 24. Yeah, about 5.2 days. All right. Okay, do you have anybody, just for the heck of it, do you know figure out how many hours that would be?
Divided by 6. Oh, wait, no, it'd be
125.
It is 125 hours, but days and hours. So let's say,
Multiply it by 60 and then times 24.
okay, what did I do? What did I do with my calculator? What did I do?
You.
I took out the 5 days, right? Took out the 5 days.
So confusing.
Took out the 5 days, right? See, I just took out the 5 days because we know the answer is 5 days, right? And then how many hours? So I took out the 5 days. How many hours? So I've got 0.2. What do we do that? Multiply that by 24, right? So it's about 5 days, 5 hours. So I've got 5 days, 5 hours. So the answer really, I only wanted hours. So this answer is great,
This
Landon.
is a challenge question.
Yes, this answer is great, isn't it? Because that's all I've asked. So, but if we want to challenge it, it could be 5 days
This is
and 5 hours. Isn't that great? All right. All right. All right. We are not out of time, but I'm going to have you do one thing real quick. All right.
We finish this for homework.
No, because you're not going to be able to. Okay. So what I want to do real quick is I want you to make. Okay. Pass the scissors around. Okay. Because we're going to make a blob. Pass the scissors around. Okay. Okay. Pass this around. No. No calculator. Okay.
What am I doing?
Hang on to it.
You're gonna do this tomorrow?
No, we're going to do it right now. We'll get time. Okay. All right. Sasha? Okay, you guys watching? Ryan, you need a pair of scissors.
Okay.
Okay, and Torn, you need a pair of scissors.
And then you need to do
Not yet. All right. And we're going to pass the scissors and the paper down. So, ready? You don't need any more than about that much. There you go. I did yours for you. Pass it on. Okay.
Bill, you
Pass it
dropped
on.
Sasha.
I know I did. I know I did. Mr. Cat. Okay. Pass it back. Cut it. Pass it back. Do not lose this. Do not lose this. Okay.
Are you sure?
Okay. Pass it back. Okay. Cut yourself a corner or a piece.
Young Nick.
Okay.
Wait, can we put away the sheet?
Yeah, you put away the sheet. Okay. Everybody needs to cut a square about that big, okay? Everybody cut a square about that big, pass it back.
Sounds good.
Perfect. Can I borrow that?
Wait, why did
That's
we
a lot smaller.
Okay. So everybody needs a square about that big. When I say about, it doesn't have to be perfect, because we're going to do something with this, okay? Okay, so everybody needs to pass it back, cut a square, rectangle about that big. Doesn't have to be perfect. Looks great. Yeah, just something about that big. Okay. Pass it back. Pass it back.
Isaac, you're on campus. I like my
Landon.
Okay, now if you've got your square, cut out a blob.
Oh, I'm gonna make my face.